Hello everyone, welcome to Code Enzyme, and in this video we will discuss this D problem from Codeforces round 921 Dev 2. So before starting this video, I would like you to hit that like and subscribe button because majority of my viewers have not subscribed to my channel, and it doesn't cost you anything but it will help me a lot. So thank you, and now let's read the problem statement. There are n children in a class and m pairs among them are friends. The ith pair who are friends have a friendship value of fi. The teacher has to go for k excursions, and for each of the excursions, she chooses a pair of children randomly, equiprobably, and independently. If a pair of children who are friends is chosen, their friendship value increases by 1. The friendship value of a pair who are not friends are considered 0. And it does not change for all the subsequent excursion. Find the expected value of the sum of friendship values of k pairs chosen for the excursion, and then we have to print the fraction p by q in p q inverse mod this number. So for this there are some prerequisites. So there are a few things you should be familiar with before attempting this question. You should know about mod inverse. So there are tons of videos on YouTube, you can check them out before continuing this video further. Also you should know how to handle overflows, because if you don't know how to handle overflows, it will give you a wrong answer. Actually, even I had a problem with this on test case 4. I was getting an integer overflow. Yeah, so you should be very careful with the overflows in this question, otherwise it will give you a wrong answer. Yeah. And if we see the constraints, we have n and m are going to 10 to the power 5, and k is also till 10 to the power 5. So we have to solve it in big O of k or big O of k log k times k log k complexity. Sorry for the background noise here. Okay. Now let's see the sample input and let's try to understand this problem for those who are new. I think the first test case is quite clear because there are 0 excursions, 0 pairs, so all the friendship value is 0, so the answer will obviously be 0. Now then we have this this test case. So we have I don't know, let's first discuss the third test case because it is more interesting. So we have 3 friends, so a group of 3 friends A, B and C. Let these be the names of the friend. So for every trip I can either choose AB, BC or CA, right? And we are given that the friendship of B and A is 1. So we are given the friendship of B and A is 1, or I can say A or B is 1. So both means the same thing. Okay. So since we are going on 2 trips, so I can either take AB. In the first excursion, I can either take AB, or I can take BC, or I can take CA, right? And for the second excursion, again I can take AB, BC or CA, right? And then again I can take AB, BC or CA, and here also I can take AB, BC and CA, right? And if we see, like when I'm taking AB, the friendship value of AB becomes FAB becomes 2, right? And currently my answer is equals to 1. Here currently my answer equals to 0, and here also currently my answer is equals to 0. And if I take AB again, my current variable will become equal to 3, because I'm taking AB again, so this will get added to this. Otherwise my answer simply remains 1 in this case. So we have a 3 here, 1, 1. In this case it will be 0, B, right? So it will be 1, 0, 0. Then here also it will be 1 again because AB is 1, so 0 and 0. Now in the problem it is said that all these occurrences are equiprobable. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 occurrences and all of these are occurring with equal probability. So the expected value becomes 3 into 1 by 9. because the probability is same, right? So 1 into 1 by 9 plus 1 into 1 by 9 plus 1 into 1 by 9 plus 0 into 1 by 9, I mean so on. Basically we are taking the sum, if I take 1 by 9 common from this, I will get 3 plus 1 plus 1 plus 1 plus 0 plus 0 plus 1 plus 0 plus 0, and the sum is, I think, sum is, what is the sum? 7 upon 9. So this is the expected value of the summations, and if you see, it is written here that the answer is 7 upon 9. So I think you now get a pretty good idea of how we are getting to the answer. Now let's discuss the approach. So now we are discussing the approach of the problem. Okay. So one thing is clear that the pairs are either AB or BA means the same thing, right? First thing is this, that the pairs are necessarily mean the same thing. Now, since the taking of, like, let's say we have some friends, let's say we have people like P1, person 1, person 2 till person n. So how many pairs can I form? So I can say pairs is equals to NC2. So this is the number of pairs that I can form from this, and out of these I have m friends, right? So like if I was going on one excursion, like let's say on my first excursion, if my k was equal to 1, then let's say I have let's say I have friendship values of f1, f2 till fm, right? Then the probability, there will be a total of these many pairs, and there are only m friends. So the actual pairs are f1, f2 till fm, and the rest are 0, 0, 0, 0 till 0, such that the overall length of this is NC2, right? So this is the actual number of pairs, and all of these have equal probability. So my actual so for the first excursion, my answer will simply be summation fi divided by NC2, right? And okay, so this is actually pretty simple. I am using basic probability. So for the first excursion, my expected value of the friendship is this. So this is occurring with 1 upon NC2 probability, this is occurring with 1 upon NC2 probability, and so on. Now what happens in the second excursion? Now in the second excursion, if now some probabilities will increase, and we need to see which probabilities will increase. Like what is the probability that f1 will increase, and by how much? I think this is a bit complex to explain. Let's say the probability that fi is selected is equals to m upon the probability that f is selected is 1 upon NC2, right? And if this is selected, my f will go from f plus 1, right? So let's say a variable s, which is equals to initial summation of f of I. Okay. Now if now all f's will increase, all fi will increase by 1 with probability 1 upon NC2, right? Like fi can occur with probability fi can occur with probability 1 upon NC2, right? So this means that 1 will occur. This means or implies s will increase by m upon NC2. Do you agree with this? Like think about it. Like if my all like for the first, this is okay. But for the second iteration, my S will become S plus M upon NC2, right? So I think this is the actual approach. So first we will calculate the summation of FIs, and since the expected value is linear, there is linearity of expectation. All the things are independent here. So the probability of selecting an F is actually 1 upon this value. So this means that the S will, so I can simply, and since there are M pairs, I can simply multiply this value by M. Since one is occurring almost M times, so this will the expected value that by which my summation will increase. And for each value of K, so for I equals to 1 to K minus 1, I can say my answer is equals to summation upon NC2. Answer plus equals to, sorry. Now what is my what is this S upon NC2? So right now this is S and this is NC2. For let's just try to understand this with this test case. This here, this one. So we have 3 1 2 and 2 1 1. So currently my S is equals to 1. Okay. So currently for the first excursion, I can select, I have 3 pairs, right? AB, BC and CA. So for K equals to 1, my answer is equals to S upon 3C2, which is equals to 1 upon 3, right? And for the second time, when I go for the second excursion for K equals to 2, I can say my S will become S plus, what is the M value? 1 upon 3. So my S will now become 4 by 3, right? So this is the expected value of the summation after I go for the first excursion. And now my answer will become answer plus S upon NC2. So this will become 1 by 3 plus 4 by 3 upon 3, which is equals to 7 upon 9. So that is how we are arriving at the final answer. Now let's try to code this up. I think you now are familiar with it. Otherwise you can rewatch this video a few more times and I think you will get the approach pretty quickly. So now let's just move on to the code. So first I will make a new file. Okay. So first thing we have int n, m and k. Okay. Then actually I don't need the values of a and b. I only need the value of f value, right? So I can say okay, int s is equals to 0, and for I in range k, a, b and c, a, b, c, and s plus equals to f, c. And I should also take the modulus, otherwise this might give me an integer overflow. So this will work. Now we have the summation value of f of i's. Now what do? We need to calculate the answer. So answer is equals to s upon, actually I have to take the modular inverse. So I will use my modular inverse template. So this is something I copied from GFG. It basically calculates the modular inverse of a number. Okay. And I also need to calculate the NC2 value, right? So I can say int NC2 of n, and this I will return n times n minus 1, and let's also take the modulus again to avoid anything. Okay, times what? Mod n2, right? So modular inverse of 2, and then let's take mod again. Okay, so this will give me the NC2 value. So I can say okay, int q, the denominator is NC2 of n, and then I can say my answer is equals to s times NC2 q, and take modulus. Yeah, so this is my current answer for the first excursion. Now for the next k minus 1 excursions, I have to recalculate everything. So for iron range k minus 1, my current sum will increase by, so my current sum will increase by m upon this nc2. So let's take modulus again. Okay, so now I have increased my s, so answer will be, I will update my answer, so answer plus s times q, and let's take the modular again. So this actually, this step is what? This step is, this corresponds to this here. So actually I am adding my, sorry, actually I am increasing my s by this value here, and then I am increasing my answer for every kth excursion like this. So s is equals to this value. So now in the end I have to print my answer. And before running this code, let's see, this should be actually m, because we have m pairs and not k pairs. Sorry about that. And this q value, actually I wanted to calculate 1 upon q, not q. So I will use modular inverse there, mod modular inverse of nc2. So now this should work, and let's try to run this. So it gave us a correct answer. Now let's try to submit this and see if it is actually working. So good trip and submit. Okay, so our solution got accepted, and if you learned something, kindly like this video and subscribe to my channel. I will see you guys next time. Thank you.